Hey, welcome to MetaScript. Let's go directly to the code. I have an empty project here, no file, and then I create hello.ms. In here we can write just normal TypeScript, hello world. To be able to run MetaScript, you would need to have the command msc run, and then the name of the file. It's just a simple hello world. Now let's add more stuff into the example. I'll create interface of name is account, name is string, balance is number. Let's create account equal to type of account equal to name CL, balance 100, for example. And try to print that out. So print the account, run program again. So we see the interface print out. Now let's make it more interesting. We create a sync function, create account, which return promise account, and then just return this. We can have a name string as param and then receive that here, and let's have a run function that is also async, so return promise void. We create account again, but this time it's from the create account method that we create above. The name is CL with dot, and finally execute the run function. Now let's run the game. It works like before, but this time under asynchronous execution. Now let's add more advanced features to the program using the example here. In that case, we create a function named max. It's a generic function that receives t. So we have two params, and they need to have the same type, and the return type is also t. It's basically pick the param that is bigger and then return that. Now I will console.log max with t is number, so 10 and 9, and then print that out. It should be 10 because 10 is bigger. And now we call max function again, but we don't use number, we use abc string and x, y, z string. Which one is bigger? X, Y, Z, because it is in the later part of the alphabet order. So now we have a sync generic interface, and they're all working together, a normal TypeScript program. So what if I execute it using bun? So hello.ms, it will produce the same result. So MetaScript is designed in a way that it's interlop and respects existing ecosystem very much. So we can mix TS file together with MS. For example, I will just cut these two functions to util and export out. So we have accounts, and we also have create account purely in TypeScript. And from hello.ms, now we no longer have those kind of stuff. Now I will import from that util file, and we don't even need to have TS extension. MetaScript support that. We're automatically trying to figure out which is the proper extension to use. So now I don't think we need to import account, just create account. And then we have all the signatures. MetaScript, LSP, understand TypeScript, and all the signatures that from TypeScript. Let's try to run the program again with MSC command. You see everything's still working. We mix TypeScript together with MetaScript because it is system programming language. MSC built hello.ms would actually create the binary output for the hello program. We can see it here. So hello. So hello is a binary of size like 88 kilobytes. We can run it directly. Hello. So there's no compilation. This is just standalone program. You can do CLI with this or server. I guess you also notice that we have C file here. So actually, the way MetaScript works is it produces C code. It will parse this source into AST and then analyze the program and then generate C that is executable, and then compile C. So we have the binary. That brings us to another interesting stuff. I'll show you. In standard library, we have standard OS index. We have os.h, which is C code in C, and then we import it directly from MetaScript. And MetaScript understands C. You can go to definition, and this is actually os.h file, the struct for CPU info. We can import and use C directly as it's natively part of MetaScript. Let's go a bit further on this topic. We have Void. This is game engine built on top of MetaScript. The point is that we can use C natively without any LFI or overhead in MetaScript. You see, we import C method directly from .h file and then call it. This is the main file for desktop, and this is for browsers. They are sharing the same render. What is this one? And I will try to run it. Run source main.ms. This is for desktop. So the result is that we can create a window and then render a 3D cube inside using door. So this is a very basic example on how we can use native C library like Dawn to render. And also for the Windows creation, we use STL. The binding is pretty straightforward. Or even more interesting, we have this web build using this file main.wasm MetaScript, which we can run inside browsers. The same code base that is able to run inside desktop and also on the browsers. To push it a little bit further, I will show you another example. This is a Xcode project that is also using MetaScript. We generate C code from our MetaScript, and that's the interlock with Swift to render things natively in place like Apple Watch. A 3D games inside the Apple Watch. A DOM simulation with 60 FPS inside the Apple Watch. Here you see. This is a very portable, very small program, small binary, good memory consumption, and run on device like Apple Watch, IoT. Okay, let's back to our example here. I want to show you one more thing. MSC build can be used to produce the binary for another platforms, just to cross build. Let's open that. This is the binary for Windows, 100 kilobytes. This is binary for this Mac OS. So now let's go to the Windows simulation. Here's the PowerShell on Windows. I can just execute the file that we copy into the desktop here, and you will see the same result, but now for Windows. Let's continue with another use case that I think very good for MetaScript. AWS Lambda function. Now I create lambda.ms. To be able to run Lambda, we need to have the library that is designed for this kind of case. We can add that by msc add MetaScript lambda runtime is the name of the library. We need to init it first. Now add the library. What it does is to create build.ms and then add the dependency for you. After you install the library, you can import it. This is the most minimal forms of the lambda function that can be executed. Let me show you the actual source of that lambda runtime library. So this is the source of that library, and this is the example that we have just seen before. It's already configured to be able to deploy to AWS. Basically, a build command that is target to OS is Linux and CPU is ARM. Let's try to deploy that. cd to example API gateway hello world and run deploy production, which is this command. It's basically deployed this program at AWS. You see, this is the deployed endpoint here. we can route and serve. The program is essentially responds with request ID from the Lambda runtime. Actually, I think this could be better by just let's try make it even more simple. Body JSON dot stringify method request dot method path request dot path and request ID equal to request dot request ID would be the same view message. This is from MetaScript. And deploy again, build and deploy it again. In the meantime, build is generate under build and bootstrap. This is everything we upload to AWS, so around 80-90 kilobytes. Okay, we have deployed. This is from MetaScript, and everything else is the same. So it's quite straightforward for us to build AWS Lambda function with MetaScript. And now I think we can go to the last example, this program, server.ms. Besides Lambda, we can also have traditional server with MetaScript using standard HTTP. Let's run it. So I will run a server. This is a very basic ping pong example that when you request a page, ping will say pong. It's very similar to how Node.js works. The only difference is that because MetaScript is system programming language, so serve concurrent here use threads from real CPU power, which leverage all the CPU power that we can leverage on a machine. So I think we already have a good understanding on how MetaScript is about. And there's many other interesting things you can find under metascript.org homepage. The compiler is still early, and it would need more time to get more and more stable. But in the meantime, welcome to go to installation page and get this compiler installed in your machine and try it and let us know how you think about the compiler. See you.